The heights of a random sample of 1,000 students were collected and recorded. A. Tick one box from the table below to indicate how you would categorize the type of data collected and explain your choice. So the options are categorical nominal, categorical ordinal, numerical discrete, or numerical continuous. So tick a box and explain why. So height is numerical continuous data. So height is definitely going to be numerical. So someone could be 165 centimeters, 179.8 centimeters, and so on. So it's definitely numerical. And it's continuous because height can take any value. So it can be a decimal or a fraction. So it can be a range of values. Whereas numerical discrete data must take a certain value. So for example, if you wanted to record the number of family members each student has in a class, well, one student might have 3 family members, another student might have 4 family members. No student would have 4.5 family members or 3.2 family members. So numerical discrete data is number data that must take a certain value, whereas height, weight, time, length, distance, mass, volume, and so on is numerical continuous data. Categorical data is word data. Ordinal means it must be in a certain order, so days of the week must go in the order Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Months of the year is word data as well, so if you're taking a list of the students in the class's birth month and you wanted to order them, it would start January, February, March, April, May, and so on. So categorical data is word data, and ordinal is where it must go in a certain order. Categorical nominal data is also word data because categorical is word data, but nominal has no order. So if you asked the students in a class what their favourite food was, someone might say Chinese, another person might say pizza, another person might say chocolate. So that's word data, but there's no order to it. So categorical data, word data, numerical data, number data, and height is definitely continuous data because it can take any value. So our explanation, height is a number, so numerical data, and can take an infinity of values between any 2 consecutive whole numbers. B. The sample of 1,000 students was made up of 500 boys and 500 girls. The data from the 500 girls was used to create the information shown in Table 1. So here we have Table 1, and it's just for girls, so the 500 girls, this is their information. So the first row shows the height in centimeters, and notice that it's a grouped frequency table. So for example, 145 to 150, there are 15 girls whose height ranges between 145 and 150 centimeters. So we don't know exactly what height these 15 girls are, but they range somewhere between 145 and 150 centimeters. Likewise, there are 48 girls whose height ranges between 150 and 155 centimeters. And likewise, there are 80 girls whose height ranges from 155 to 160 centimeters, and so on for the rest of the table. Part 1. Use the information in Table 1 to estimate the mean height of the girls using mid-interval values. Part 2. What is the largest possible value for the range of the heights of the girls in this sample? Okay, so we need to get the mid-interval values of each of the grouped frequencies. So 145 plus 150 divided by 2 is 147.5. So that's halfway between 145 and 150. And likewise, 150 plus 155 added together and divided by 2 is 152.5. So again, this is the midpoint of 150 and 155, or the mid-interval value. And likewise, 155 plus 160 added together divided by 2 is 157.5. So again, this is the midpoint between 155 and 160, or the mid-interval value. And again, likewise, 160 plus 165 added together divided by 2 is 162.5. So again, this is the mid-interval value. So we do that for the rest of the values. And we get 167.5, 172.5, 177.5, and 182.5. So we are trying to come up with the mean. So what we're going to do is multiply 147.5, so the midpoint or the mid-interval value, by the frequency, the number of girls, which is 15. So it's going to be 147.5 multiplied by 15. And then we're going to add that to 152.5 multiplied by 48. And then we're going to add that to 157.5 multiplied by 80. And then we add that to 162.5 multiplied by 112. And then we add that to 167.5 multiplied by 125. And then we add that to 172.5 multiplied by 81. And then we add that to 177.5 multiplied by 29. And then we add that to 182.5 multiplied by 10. And you can just put that straight into the calculator. I would suggest doing it a couple of times because you could easily go wrong with this. And you end up with 82,215. So this multiplied by this plus this multiplied by this plus this multiplied by this and so on the whole way along. And we get 82,215. Next we add up the frequencies, so 15 plus 48 plus 80 plus 112 plus 125 plus 81 plus 29 plus 10 is equal to 500. Now we already knew in the question that there were 500 girls, but just to confirm we can add up these frequencies, the number of girls. And then dividing 82,215 by 500, get 164.43 centimetres. So this here is the mean height of the 500 girls. So next we want to find the largest possible value for the range of the heights of the girls in the sample. So we take the highest or the largest height, which is 185, and we subtract the lowest height, or the smallest, which is 145, and 185 minus 145 is 40 centimetres. So this is the largest possible range for the heights of the girls in the sample. Now it's not necessarily the actual range, because remember we don't know exactly what the shortest girl is. We just know that these 15 girls are the shortest of the whole group and that their heights ranges from 145 to 150, but we don't actually know what their actual height is. So this is just a possible value for the range. Question 3. The median height of the girls in the sample is 164.5 centimetres. Explain what this means in the context of the heights of the 500 girls. So the median height means the middle height. So if we were to write all the heights of all the girls out in a list and pick the one in the very, very middle, it would be the median. So this happens to be 164.5 centimetres. So we have to explain, what does this actually mean? Well, if there's 500 girls in total, then half of 500 is 250. So half of the girls are shorter than this and half of the girls are taller than that. So half of 500 is 250. So 250 girls are 164.5 centimetres tall or taller, and 250 girls are 164.5 centimetres tall or shorter. So half of 500 is 250, so half of the girls are this height or shorter, and half of the girls are this height or taller. See Part 1. Use the data in Table 1 to complete Table 2 by finding the percentage of girls in each of the height categories. So here's Table 2, which is the girls' percentage. We're given 2 of them, and we have to fill in the blanks to come up with the percentages. Okay, so remember there are 500 girls in total, and in Table 1, if you look back at Table 1, you'll see that for 145 to 150 there was 15 girls. There was 15 girls who ranged between 145 and 150 centimetres. So 15 divided by 500 and multiplied by 100 gives us 3%. So likewise, if you look back at table 1, you'll see that for the 150 to 155 range, there were 48 girls. So 48 divided by the total again, which is 500, multiplied by 100 is 9.6, so 9.6%. And similarly for the rest, 80 divided by 500 multiplied by 100 is 16%. 112 divided by 500 multiplied by 100 is 22.4%. And similarly, we get 25%, 16.2%, 5.8%, and 2%. Part 2. Use the data in Table 2 to draw a histogram showing the percentage of girls in each height category. So this is the girls' height. So we have an x-axis and a y-axis. The x-axis is the girl's height in centimetres, the y-axis is the percent. So we just have to draw a histogram, which is similar to a bar chart, but the bars are stuck together. So we can see there is a histogram drawn already for the boys. So it's going to look something very similar to this. So using your percentages from table 2, so for example, between 145 and 150, we have 3%, so we go up as far as 3. Draw a line across and a line down. For 150 to 155, in table 2 we had 9.6%. So we draw our next bar up as far as 9.6. For 155 to 160 we had 16%. So we draw our third bar up as far as 16, and so on. The next bar goes up to 22.4. The next bar up to 25. The next bar up to 16.2, the next bar up to 5.8, and the last bar goes up to 2. Question 3. A histogram showing the percentage of boys in each height category is given above. John examines both histograms and comments that there are roughly twice as many boys as girls in the 175 to 180 centimetre category. Do the histograms support his claim? Explain your answer. So you have to say yes or no and give a reason. This is very important. If you do not get a reason, you will not get marks. So we can see that from 175 to 180 for the girls, we are going up as far as very close to 6. Very, very, very close to 6%. And for 175 to 180 for the boys, we're going up to very, very close to 12%. Very close to 12%. So we would say yes. The area of the bar for the category 175 to 180 in the histogram for the boys, so it's highlighted in yellow, which goes up as far as about 12%, is approximately twice the area of the corresponding category in the histogram for the girls, which is in green, which is going up as far as almost 6. So 6 multiplied by 2 is 12, so it is indeed pretty much twice the area. Part 4. Mary examines both histograms and comments that I see that there are more tall girls than tall boys. Do the two histograms support her claim? Explain your answer. Again, you have to answer yes or no and give a reason. You must give a reason. And the answer is no. The combined areas of the categories from 165 to 185 centimetres is greater in the histogram for boys, indicating that there are more boys than girls with a height greater than 165 centimetres. So if we're choosing to call 165 tall, and obviously anything after 165 or greater than 165 is also tall, and we were to have a look at the areas, let's start off with the girls. So the girls in this bar, 165 to 170, is about 26%, and then we were to add that on to the area for 170 to 175, which is about 16%, and then add that to the area of 175 to 180, which is just below 6%, and then add that to the 180 to 185 height group, which is about 2%. If we were to add those up, And then do the same with the boys. So we have from 165 to 170 centimeters, we have about 19%. Then from 170 to 175, we have about 17%. And then from 175 to 180, we have about 11%. And then from 180 to 185 centimeters, we have about 9%. So to add these together, this area would be more than this, which would tell us that the combined areas of the categories from 165 to 185 centimeters is greater in the histogram for the boys, and this indicates that there are more boys than girls with a height of greater than 165 centimeters. But you can clearly see that there is more area covered in yellow than there is green. There are quite a lot of girls from 165 to 170 centimeters. We can see that there's about 25-26% of girls that tall, but we don't have very many from 175 to 185, whereas for boys there's quite a few. So although here it seems that there is not as many boys, there are certainly not as many boys from 165 to 170 centimeters in height as there are girls. This bar is definitely higher than this bar, but if you were to take the 4 bars together, there's definitely more area covered than these 4 green bars together. Now you could say the exact same thing if you were to just decide that 170 centimeters is tall. So if you were to just focus on 170 to 185, so ignoring this first green bar and ignoring this first yellow bar, it would still work out that the boys, there's more area for the boys in the histograms, which means that there are more tall boys than there are tall girls. D part 1. The mean height of the boys in the sample is 166.7 centimeters and the standard deviation of their height is 8.9 centimeters. Assuming that boys' heights are normally distributed, use the empirical rule to find an interval that will contain the heights of approximately 95% of all boys. Part 2. The standard deviation of the heights of the girls in the sample is 7.7 centimeters, while the standard deviation of the heights of the boys is 8.9 centimeters. Interpret this difference in the context of the data. Okay, so we're going to use this little formula to help us here. So x bar, so it's x with a little bar on top, is the symbol that represents the mean. And we know that the mean height of the boys is 166.7 centimeters. So we take the mean height and we subtract 2 times the standard deviation. So this little symbol here, it might look like a 6, but it's not actually a 6. This symbol here is for standard deviation, and the standard deviation we were told is 8.9 centimeters. So if we want to come up with an interval that will contain the heights of approximately 95% of all boys, we use this little formula. So it's going to be the mean minus 2 times the standard deviation, comma, the mean plus 2 times the standard deviation. And that gives us the interval. So the mean is 166.7 centimeters. The standard deviation is 8.9 centimeters. So we're going to add and subtract 2 times 8.9 to 166.7. And you can put it straight into the calculator. So 166.7 minus 2 times 8.9 is 148.9. And 166.7 plus 2 times 8.9 is 184.5. So this is our interval. So we've found an interval that contained the heights of approximately 95% of all boys. So that is between 148.9 and 184.5. So part 2. The standard deviation of the heights of the girls in the sample is 7.7 centimeters, while the standard deviation of the heights of the boys is 8.9 centimeters. Interpret this difference in the context of the data. So we can see that the girls' standard deviation is 7.7 and the boys' standard deviation is 8.9. So 8.9 is clearly bigger than 7.7. So this means that there is a greater spread about the mean in the heights of the 500 boys than there is in the spread of the girls about the mean height for the girls. So the spread of the data is like the range of the data. So the boys' standard deviation is 8.9 and the girls' standard deviation is 7.7. So there is a greater spread for the boys. The other heights are further away from the mean. There is more of a gap between the heights of the boys and the heights and the mean height of the boys. Whereas for the girls, the standard deviation is lower, which means that most of the girls are closer to the mean height.